right, we're going to use Excel to determine present value of houses and other items. And I'm going to do this without actually using Excel, but I will be showing Excel functions. So if you have Excel, it might be beneficial for you to stop periodically, plug these functions into Excel and see how they, shoot you answers. So we're going to assume that Brian and Jane choose the 30-year fixed rate mortgage at 4.25%. And we now know that Brian and Jane can afford a monthly mortgage payment of $875. We used the total expense ratio in a previous video. So Excel uses this information in what we call the present value function to calculate the mortgage value based off of their monthly payment. Okay, so Excel gives us this formula. Monthly interest rate. So basically, you take your APR and you divide it by 12. The number of payments, well, there are 12 months in a year and however many years in the loan. And then you have your minus your, I should have made that a dollar amount, minus the dollar amount that you're paying. Okay? So PV, present value. If you're trying to find the value of something, the house, the car, the boat, PV is your function. So for Brian and Jane, this is what they would type in. 4.25% is 0.0425 divided by 12, as we mentioned. 12 months in a year, and they have a 30-year mortgage, so there's the 12 times 30. And their monthly payment is $875, which is why it's the negative $875 there at the end. Excel, if you type that into Excel, just like you see it right there, just like you see it, Excel is going to spit out at you $177,867.26. This is the top end of the house Brian and Jane can afford. Anything above that is going to put them in financial despair, or at least make things very, very tight, which nobody likes. All right, so now let's say, pretend they want the 15-year mortgage. So they can get a 15-year mortgage at a rate of 3.5%, still using $875 as their monthly payment. So in Excel, we would type in PV. We start with the interest rate, 0.035 divided by 12, because they're making 12 payments a year. Inside, okay, we're doing 15 years, so 12 months in a year times 15 years in the loan, and again, they're making payments of $875. Now, if you type this into Excel, just like you see it, it should spit out $122,397.73. Which means if they want to do a 15-year mortgage instead of a 30-year mortgage, they can afford about a $50,000 less of a house, right? But that's all you need, then that's good. You're going to save yourself a lot of interest that way. Okay, number 2, Brian and Jane find a condo for $121,000, but they choose to borrow the exact amount that we just determined, the $122,397.73. How much will they pay in interest for this mortgage? So in words, if we think about this, the total payback minus what you borrowed will give us the interest, right? Because the difference between the amount you borrow and the amount you pay, that's the interest. So how much do they pay back? Well, they're paying $875 a month for 12 months for 15 years. Right? We are assuming they only make the $875 payment. They never pay more than that. That's our assumption. Okay? Which means they will pay back roughly $157,500. We know that they borrowed $122,397.73. So if we subtract those, the difference between the borrowed and the payback is $35,102.27. That, my friends, right there is the interest. And then number 3, you can use that PV function for other things besides houses, like in this case, a car loan. So Sierra can afford to spend $300 a month on car payments. Let's use the PV function to determine how large of a car loan she can get with a 3.25% APR for 72 months. Notice how right here they give you 72 months. So you don't need 12 months in a year times however many years, because they give you the number of months already. So, PV function. We start with our interest rate, 0.0325 divided by 12, because she's still making monthly payments for 72 months, and she can afford $300 a month. Again, type that into Excel exactly like you see it, and Excel is going to spit out at you $19,600.44. So she should be looking for a car loan less than $19,600. If she does, she's going to be fine. Anything more than that, and again, it's going to be really tough financially for her to handle all that.